Hello and welcome to the Chandara Academy. Sumsakon Mokan Chandara Academy. In today's video, we are going to calculate the following limits. Those are two limits when x tends to 0, which will have the form, obviously, this thing will tend to minus 2 sinus of 0, which is equal to 0, over 0, when x tends to 0. And 0 over 0 is a non-defined form. We cannot conclude just having this information, and so we will do a little work on this expression. This one will be almost the same, a 0 over 0, and this expression to be able to conclude on the value of the limit. Let's start with the first one. We see that we have sinus of something that will tend to 0 over something that will tend to 0, and this thing has to make you remind directly of the limit that you know. Limit when something tends to 0 of sinus of this thing over this same thing is equal to 1. You have to know this. Where does it come from? It comes from the fact that if you make appear here as minus sinus of 0, because obviously sinus of 0 is equal to 0, minus 0, you have here the exact definition of sinus prime, so the derivative evaluated in 0. And sinus prime of 0 is equal to cosinus of 0, basic trigonometry, is equal to 1. Perfect. So what we want to make appear in conclusion is sinus of something over the same thing. And here it will be a lot easier to manipulate what's at the bottom to look like what's inside of the sinus than the other way. Let's do it. So let's call this thing f of x. F of x, for all x of course different from 0, f of x is equal to minus 2 sinus of 3x over x. What I'm going to do here is just to make appear a 3 at the bottom. What do I do in this kind of situation? I'll multiply by 3 at the bottom, but I also have to do it at the top. And now I've got this thing equal to minus 6, so minus 2 times 3, sinus of, let's say, capital X over x, when x is equal to 3 little x, obviously. And a, which is equal to the limit when little x tends to 0 of f of x, is the same thing, because when little x tends to 0, capital X obviously tends to 0. Then the limit when capital X tends to 0 of f of x, which is equal to minus 6 times 1. Okay, because sinus of x over x tends to 1 when capital X tends to 0. And so we can minus 6 times x over x, so the limit when x tends to 0, and this thing is obviously equal to minus 6 times 1 is equal to minus 6. And we've got our limit, a is equal to minus 6. Perfect. Now it will be a little bit faster with this one. Here what do we have? We have sinus of, let's call it g of x, for all x different from 0, obviously g of x is equal to sinus of 5x. We still have sinus of 5x over what? Over something that will go to 0, but this time we have a square root, and we hate square roots, okay? So square root, we hate it. We hate it. Absolutely, okay? So how do we get rid of the square root? We use this identity a squared minus b squared is equal to a plus b times a minus b. And here I can identify this as a and this thing as b, and get rid of both by multiplying at the bottom and at the top by a plus b. Let's do it. G of x is equal to sinus sinus of 5x over what? Still square root of x plus 1 minus 1. But this time I will multiply by square root of x plus 1 plus 1 at the bottom, but also at the top. X plus 1 plus 1. And at the bottom, this will simplify into square root of x plus 1 squared, which is equal to x plus 1 minus 1 squared, which is equal to minus 1. And this plus 1 and this minus 1 will cancel each other, and we will be left with x. And now this is very easy, because we just have to make up here this thing will have a limit in 0, okay? This does not cause any problem. But for this one, sinus of 5x over x, we just have to make up here a 5 at the bottom and multiplying by 5 at the top. If I rewrite this, I have 5 times square root of x plus 1 times sinus of 5x over 5x. And this thing will tend, when x tends to 0, to what? To 5 times this thing here will tend to square root of 1 plus 1, very easy, times 1. Times 1, because this thing here is the limit of sinus of x over x when x tends to 0, obviously. And this is this one here. And if I just do the calculation, this thing is equal to 5 times 2 times 1, which is equal to 10. And this thing here implies that the value of b, which is the limit, is equal to 10. And here I have solved the whole exercise. I hope you enjoyed the video. See you soon. Bye.